There you go. Okay, so this section is all about present value versus future value. What I'm doing in the first box here is I'm going to give you the difference sort of between the two of these things, okay? So the guiding question I have on the left is just sort of, what's the difference between present value versus future value? PV stands for present value. FV stands for future value, obviously. Okay. So for future value, that's basically asking yourself this question, right? How much money will I make or have at a later date and time? And what we did in our homework last night is a prime example of what we're doing with future value. So, okay, I have $100. I put it in the bank at 1.5%, compounded semi-annually for 30 years. I come back and I have $101. Great, amazing. That's future value, okay? Hopefully a little more than $101. Okay, so present value works a little bit differently, right? The difference between present value is, okay, how much do I have to have today in order to get a goal of X amount of dollars later? So retirement funds, annuities, those sorts of things, right? Retirement funds are the big ones, or if you want to watch your money grow. Like, I think it was in our video yesterday, was it Jasmine in the little stick, the cutout girl yesterday? Right? The little, she was like, okay, I want to buy a house in 30 years. I want to have a certain amount of money. I'm going to plan for that. That's present value. And it seems kind of weird because, you're planning for the future, but we call that present value in future value. So let's review yesterday. We discussed two equations that we did yesterday for present value. One of them looked like this. A is equal to P times 1 plus R over N, all to the NT. And when do we use this one? When we have what? Anybody remember from yesterday? Yeah, payment periods, right? When we have payment periods. So when we have payment periods, we use that one. And then there was another one that we used when our payment periods were sort of continuous. And what was that formula? You got it. PERT. P-E to the RT, right? And this is compounded continuously. Okay? So all these are future value equations, right? How much money will I have later given that I have this much money now and I leave it in the bank for so long at a certain rate, compounded a certain way, right? That's all review from yesterday. Is that making sense to you so far? Yeah. Okay, great. Now, the cool thing about present value is that you can actually just use the same equation. So instead of solving for A, we're going to solve for P. So if you think about it, how could I solve the equation over here for P? Well, I would just divide everything by 1 plus R over N to the NT. So I would have something that looks like this. A divided by 1 plus R over N to the NT is equal to P. Then if I wanted to clean this up a little bit better, I would say P is equal to A times 1 plus R over N. I'll just raise that to the negative NT, and I have my future value formula. Does anyone see what I did there? Yeah. I just used the properties of exponents, right? If I'm dividing exponents, I can bring it to the top and make the exponent a positive value. So this is a a present value equation for payment periods. Okay, I'm pretty sure you can guess what the other one is going to be. So P would be A e to the what? Negative RT. You guys got it. That's beautiful. Yes. All right, there we go. So we got a clear distinction between the ideas of present value versus future value? Yeah? Okay. And yesterday we had a lot of practice with future value, so today we'll do a lot of beautiful. Okay, let's keep going here. All right, let's do number 2. I'm going to read you a story. I want you to pick out the important information that you need from that story in order to answer the question. Okay, I'll read the story twice. Here it goes. Sally wants $1,000 in 5 years, invested at 1.5% compounded monthly. How much does she need to walk into the bank with today? So I'll read it again. Sally wants $1,000 in 5 years, invested at 1.5% compounded monthly. How much does she need to walk into the bank with today? Did you get all the crucial information?
Yeah.
Okay, good. Let's see here. What is the value of A? $1,000. Good. What's the value of P? That's the thing that we're looking for, so we'll just call that the ever fun X, right? Okay, what's the rate? 1.5% translates to 0 or 0.015 as a decimal, correct? Everyone can change a decimal to, a percent to a decimal, right? N, how many times is this compounded? Monthly equals 12 for N, and what's the time? 5 years. Good, so that's the important information, right? Okay, great. Before we begin, let's have a little bit of fun here. Take a guess. Just write your guess down to the left-hand side. And now, it better be less than $1,000 because you're trying to achieve a goal of 1,000, okay? Okay, so we've taken some guesses here, and we think that we have to walk into the bank with somewhere between $169 and $950 to get our goal of $1,000 in 5 years, compounded monthly at 1.5%. All right, let's figure it out mathematically now. So I'm going to use which formula, you guys? The top right formula, correct? Okay, so I'm going to say that P is equal to A 1 plus R over N to the negative NT. So the P that I'm looking for, just leave it as P. The amount is $1,000 times 1 plus the rate, which is 0.015, divided by 12, all raised to the negative 60. Somebody tell me where did I get negative 60 from? Yeah, I multiplied the 12 and the 5 together, made it negative, and put it up in the exponent. All right, let's get our calculators out. I'll show you how to do this now. Calculators out. We're going to do the inside part first. So parentheses, 1 plus parentheses 0.015 divided by 12. Close parentheses, close parentheses. Now that number is, I got 1.00125. Now I need to raise that power, or raise that to an exponent of negative 60. Please make sure that you use the negative sign, which is the one that's below the 3, not the minus sign, okay? So hit enter. And notice that this number now is less than 1, right? Which it should be, because we're going to multiply this by 1,000. That's going to give us something smaller than 1,000. So we're going to multiply that by 1,000. And lo and behold, we better walk into the bank with $927.77. Wow, that's pretty good. So it was $927 and what was it? 79 cents. Okay. And that is within a reasonable guess of $169.950. Now, yeah, I can think of 2 reasons right off the bat why this isn't such a great deal. I mean, it's a good deal. I mean, you're making money, but like, how come I needed so much money up front? There's 2 reasons I can think of. Daniel, you think of one?
Yeah, because you're only getting 1.5%.
That's right. My rate is pretty small. I'm only getting 1.5% on my interest. What's another reason why this is not a huge amount? Yes?
Because you're only doing it monthly?
I'm only doing it monthly. Okay, maybe.
It's only like
Compounded monthly, that might have something to do with it. I could do daily and maybe get a better rate, but I think there's something that's more significant along with that. What do you think? Yeah, it's only for 5 years, right? It seems like an eternity when you're in high school, right? But 5 years is actually not that long. So if I wanted to get a better, if I wanted to get $1,000 and I had less than 927, I better have either A, a better rate, or B, a longer amount of time I can wait. You guys get the concept there? Question. Okay, so number 3. Let's go to this one. Okay, I want you to think about something that's a little strange, okay? Well, get yourself set up here. The APRNT. Okay, now, do we have anybody in this room who's 14? We have a 14-year-old? Good. Do we have a 15-year-old? Good. Do we have a 16-year-old? Do we have a 17-year-old? No 17-year-olds? Okay, do we have an 18-year-old? We don't have any of these? These are done? You're 18? You're not 18. Goofball. Okay, so we have no 17-year-olds and we have no 18-year-olds. Do we have any 31-year-olds in the house? No, it's me. Okay, great. Here's what we're gonna do. So, 31. I know, old guy. Okay, so imagine right now. Imagine yourself. Close your eyes and imagine yourself at the age of 65. Super, super, super scary, right? Okay, imagine yourself at 65. Now imagine that you also have a grandchild. Gasp. You have a grandchild, okay? And you'd like to give that grandchild the gift of money for college. You want to give your grandchild $35,000 to start them off on their college career that will get them about a day and a half at Berkeley. Okay? So, the question is, how much, assuming that you're going to run to the bank after school today, how much would you need today in order to start saving up to get to $35,000 for your unborn grandchild? Here's a couple of things that you need to know, all right? A is going to be what? $35,000, okay? So that's our goal, $35,000. That's a decent start on a good college education, all right? P, that's going to be the thing in question. That's what we're looking for. The going rate at the bank when you walk in there was 3%. There it is. Was 3%. It was compounded quarterly. So that means 4 is going to be for N. And then the T, well, that's going to be different for everybody. Since at 65, well, I'm 31 right now, so that means I've only got 34 years left. So my T is going to be a 34. Go ahead and figure out what your T is going to be. It's going to be different for all our different ages in the classroom. 65 minus your current age, whatever you are now. That's how much time you have until you're 65 years old, right? I've got 34 more years, and then I'll be 65. Sweet.
At least you're not almost halfway there.
Yeah, you know what's scary is like last year in my notes though I put a 30 there. I know, I'm just getting old. All right, right now go ahead, figure out whatever. Okay, so taking a look at all the work that we did, if you're 14 years old right now, okay, you only need $7,620 today, all right, to walk into the bank for your unborn grandchild to go to college for $35,000 when you become 65. I mean, now here's what I want you to take from this, okay? How come I have to put $12,295 in and you guys only have to put in $7,000? Yes. Mr. Brim, what do you have? Yeah, that's right. You guys have the gift of time, right? It doesn't seem like it's a gift, but it actually is. You guys have this gift of time that I don't have, right? I have to start like upping my game in order to match you guys, almost double, right? Once you get up there. So save for your grandkids. There you go. That's your right there on the left-hand side. Okay, let me give you one more example. Number 14. Okay, what does the E mean there? Yeah, that means it's compounded continuously. And so since we're trying to find the P, the present value, right? So we're going to say P is equal to A times E to the negative RT. So P is going to be 6,000 E to the negative 0.025 times 15. So let's figure out what P is together. So here's our calculator. Turn it on, clear it out.
Wait, how many? It was 12 years, right?
No, 15 years. So we're going to do second natural log. And then that's going to give us e to the, we're going to say negative 0.025 multiplied by 15. That should give you a number that's less than 1. And of course it is. Now we multiply that by 6,000. And we need $4,123.74. So $4,123.74. Yeah, it'd be something like this. You got it. Okay, last idea. The last idea. There you go. $4,120.74. Okay, last idea is this time and this idea of doubling your investment. Okay, what we're going to do is we're going to find the rate of interest that's required to double an investment. Okay? So we want an annual rate of interest compounded annually. So if it's compounded annually, that means it's going to be once per year. This is just an example I'm giving you on how to do this. If you want to double your investment in 10 years, so in 10 years you want your investment to double. Okay, the rate is the thing that we're looking for. The principal, or the amount you're starting with, is whatever that amount actually is. Whatever it is, it actually doesn't matter. Just start with something. But here's the trick. What do you want the A to be? 2P. You got it. Twice your amount you're starting with. So we're back to the future value equation, the one we learned yesterday, where it said that A is equal to P times 1 plus R over N to the NT. We're going to replace A with 2P because we want our investment to double. 1 plus R over N to the NT. Now, here's the cool part. What happens to the P's? Yeah, so it doesn't matter the amount you're starting with, right? Whatever it is, it doesn't matter. So 2 is going to be 1 plus R over N, in this case, is 1. To the NT, that's just going to be 10. So we have this 2 is equal to 1 plus R raised to the 10th power. N times T. N times T. 1 times 10 is 10. You guys with me so far? Okay, I need to solve for R. So I need to take the 10th root of this stuff. So the 10th root of 2 is equal to 1 plus R. So the rate that I need is the 10th root of 2 minus 1. Well, that doesn't do anybody any good, so let's actually figure out what that rate actually is. Yeah, I'm getting the 10th root of 2 minus 1 today. That does not help me. Okay, so how do you do the 10th root of 2 on your calculator? Yes, before you do that, to hit the 10, right? Because we want the 10th root. So hit the 10, then go to math. And notice on option 5, you have that x and then a square root. That's the 10th root of, or whatever root you want. So the 10th root of 2, push enter. Thank you very much. Gives me that, and then I need to do what to it? Subtract 1. Multiply by 100. You got it, buddy. And then you need 7.2% to double your investment in 10 years, which ain't going to happen. To get the percent? Yeah. So my rate would be 7.2%. I don't think no bank I know is giving 7.2% annual rate of return. That's a lot. I think I saw one in the bank that was like advertising like, I don't know, 1.1, and they were like stoked on it. I was in line. Yeah, that's what it was. It was 1.1 because I was in line at the bank. Said you need $1,000 to start. It was a classic math problem, and I was like fourth person back, so I had time to kill. So it was 1.1%, but you needed $1,000 to start it, and you couldn't touch it for 5 years. So there you go. Figure out what we'd have if you did nothing. I'm like, So you guys didn't get that? Never mind. Cool, good start.